Packages! Systems in Rust. Okay, so, packages. The second homework, High Cargo, is ready after this class. It is comically trivial. Unless it seems hard to you, then your feelings are valid. Mostly make sure you have everything set up. It's going to take like 100 million years to run this thing. So I'm making you install a Rust data frames library, and it takes like forever to download and install. And by forever, I mean like maybe up to a minute. Well, let's time it. Terminal. Control Shift plus. There we go. Cargo, new, timing test. There, we'll just do timing. CD timing. Cargo add pullers. Time cargo add pullers. Yes. I'm not showing. Never mind. Okay. I'm sure it'll show up. Okay, that took 2 seconds. Okay, and then, so I don't have to show you that because it's only 2 seconds. Nvim circ main. That doesn't seem right either? No, it seems fine. Okay. Use Polars prelude? I don't know how to do this. Never mind, we can't time it. Okay, we'll come back to this later. Okay, pretend you didn't see any of that. Okay, so, packages. They're things that contain things. Do we have an extra chair anywhere? I sure hope everyone in this classroom is enrolled in this class. Indy, go find a chair. Okay. No, you can sit in this chair, and Indy will find a chair because Indy's not enrolled in the class. Thank you, Indy. If you find more than one chair, bring them back. Okay. This department is so weird. Okay. In like a good way. It's like weird, positive. Okay. So, this is what we got going on. I waffled a lot on like homework policy, so it's always due the Friday after the week it's assigned when class would be over on that Friday. I understand that's complicated. I feel like every single time you can make homework due is complicated, so that's what I picked. So it is always due, and this is pretty easy. It's 168 plus 48 hours after the last class it was discussed in, right? So 168 plus 48, that's 216 hours. Very straightforward. Just start the clock when you leave this class, okay? We can all understand that? Okay. You have a computer. Yes, but it keeps ticking while it's closed, so you can close it and reopen it, and you'll still you progress linearly forward through time. Another thing you can do, you can count sunsets. Okay, hybrid day, build system package manager. Yeah, they've invented a new technology. I can't fidget with this because it's attached. I've been completely outsmarted. This is the most outfoxed anyone has ever been. Okay. Build system / package manager, theory behind cargo. There's a trap in cargo and how to use cargo. What's cargo? Well, rather than tell you how cargo describes itself, I'm going to first introduce slightly the idea of build systems. There's 4 build systems that are used in real life, and they are make, CMake, Bazel, B-A-Z-E-L, and Meson. And I'm not going to teach you any of those because none of them are used with Rust. Rust uses cargo for everything. But in the olden days, before all of the code was written in Rust, people had to use these other build systems. Separately from there being build systems, there's also package managers, and you should all be aware of pip, at least, if you're not aware of anything else, right? So anyways, the Rust people slammed the build system and the package management system together and called it cargo. I don't know why they did this. Okay. This is going to come down to some of the distinctions between interpretation versus compilation. I get in trouble for this every year I say it, but I think it's funny that I get in trouble for it, so I'm going to keep saying it. So I don't actually think Python's a programming language because you don't make programs in it, you make scripts, right? So we should all feel, no, we shouldn't. We specifically should not feel superior to people that only know Python after taking this class, right? I think I'm allowed to say that. You're not allowed to feel, under no circumstances should you say that's not a programming language to someone that knows a different programming language, right? Okay, and an example of 2 things that we would not say aren't programming languages. And so if you're following along on YouTube, I'm winking into the camera right now, okay, are Python and JavaScript. And they're not just, we wouldn't just not say they're not programming languages because they're popular. It's also because they aren't compiled. Okay, so this is what I mean by script, and the reason I'm teaching you this and being ridiculous about it is just so you understand something slightly different is going on with Rust than is going on with Python. I regard a script as a text file. So what do I mean by a text file? I think I had the terminal open. Oh no, we'll just open it again. Okay, so I can make a text file. Okay, there we go. Wait, the reason you have to hold shift while pressing the plus key is just because the plus key is on the equals key and it's the same key? I thought control shift was part of the hotkeys, right? So I was like, oh, control plus doesn't work. No, that does work. That's control equals that I was typing the whole time. Okay, so we can make a text file, and we can just like put some stuff in it, like print hello world. I don't know. I only know Python. Sorry. I can just save this as a text file with escape:\w and call this like hi.txt, right? And that's allowed. No one can stop me from doing that. I can save my Python file as a text file, which, by the way, is crazy. So then I can exit that. I can like see I have the file. I can see the contents of the file. I can move that file. I can just turn that file into a Python file and then magically just run it in Python. And that is so weird to me that like a Python program is just a text file that you change its name from text to Py, right? That should definitely be against the law, right? There should be a little like, not a police officer obviously, but like an anarchist that's like guarding my laptop and making sure if someone is just a text file and they try to be run as a program that they're like stopped, right? But they're not stopped, yes?
Can you get Python to just run a text file if you just don't name it Py?
Probably. Oh, no, I moved it. Okay, I didn't copy it. Wait, no, we can move it back, right? I think we should just move it. Did anyone invite you? Did I invite you?
Why is it in your release?
I bet I invited you. Okay. I bet we can name it something else. Okay, so I'm gonna name it.
hi.rs. Aren't like file extensions like not really real? Like they're just used for association with programs, but the programs actually use the magic numbers, right? Yeah. Reaffirm.
Probably. I think like in the case of the text files, there's not even magic numbers, right?
Yeah.
Yeah. So we're calling it rs. Okay. Like we can acknowledge this is weird, right? So really what the file extension for is for your VS Code and Vim syntax highlighting. Because that's probably one of the easiest ways to specify syntax highlighting. But you have to somehow specify it, right? So if I open this in Vim, wait, it's syntax highlighted as Rust, which looks basically correct? Is that what it's doing? And then if we save this as hi.py, that didn't change the syntax highlighting. Oh, because I'm still in, so I need to open. No, that still looks the same. I don't know how Vim works. Okay, I know how Vim works. Okay, so file extensions are fake. But in addition to being fake, it's objectively weird that a text file is a Python program, right? Wait, I said what up Earth? That's such a weird thing to say. Oh, because hello world. Okay, never mind, that's fine. Cool, so that's a script. I kind of think of a program as not being the same thing as a script, and the quintessential example of something I think of as a program is Microsoft Excel, which is the best program ever written, but also Firefox, which is the next best program ever written. So here's Firefox, which exists somewhere on my computer. I can probably find Firefox. Is it in Snap? Ah, that's not Snap. Yeah, so I can just look at Firefox, probably. Can I do which? What's the name of the executable? Okay, oh yeah, okay. Oh my gosh. What do I have installed? Okay. And so this is what I think of as a program looking like. And the specific thing that I'm looking for is this says ELF at the beginning, which is not named after the long-lived race from the Tolkien Legendarium that has strangely colonial undertones, right? It's named after, I think, execute load format or something like that. And that's the name of sort of a program or a file that your computer is going to read and can interpret all of the contents. And I'm guessing there's like a bunch of non-printing characters in here or something. I don't really know how programs work. But what I will say is I don't really think of this as being a script in the sense that I can't really look at this and directly tell how Python is going to run through it, right? And I think if I try and run this as a Python program, it's probably against the law. So that's banned, right? That's not allowed? Okay. Even though, right, it should be allowed in like some cosmological sense in that, oh, like Python is the command that runs programs. No, it runs text files and it like tricks you into thinking they're programs. Python itself is the program, right? So I think we're all completely locked in on that. We probably agree with my opinions on all of these things. Okay, so what is compilation? I saw this absolutely horrible YouTube short that said compilation is like an LLM in that you like write instructions into the computer and then what comes out is like something that got processed by a computer into a different format. But it's an LLM that instead of producing English produces machine code. That was horrible. That was, right? Yeah, you should all be experiencing pain right now and or not understanding what I'm talking about. Those are the two acceptable outcomes. Okay, so compilation is the process that takes text-based code and generates these executables like the ELF files, right? And so you can make a simple Hi World program, which you've done already with Rust C, and I think we can probably do that again quickly. So I can make, how do you do that? So function, is this right? Hi, something to this effect. Am I writing Rust? Does anyone know? Kind of leaving me hanging here. And then I run main. So there's multiple steps here. First I create the file, then I create something else, then I run main. And we can look at main, and look! It's the long-lived race from the Tolkien Legendarium, right? It's an executable in load format, right?
Why are you not using binary when you're opening executables?
I mean, it doesn't really matter what it looks like other than it's not human readable, right?
Yeah.
I mean, I also don't know how to do that, but the reason I don't know how to do that is because I don't care. It's dash B, right?
Yeah.
It's definitely going to be this. Wait, what?
No.
That's fake. I also like, do I have hex? It's just HX? Oh no, not for Helix. I'm trying to get hex dump. There we go. This would be my preferred way to view it. And that's too much, so we pipe that into head. And so this is what it looks like in hex. That's how I usually look at executables. And you don't really learn a lot from this other than like, presumably that's an L, because I think, is this how, does anyone know Python? Wait, why'd I check H? Wait, it's in hex, right? Is that right? Anyways, those are hex for something, right? I don't know. Wait, no, that's I just did a Vim motion to escape Python. Okay. Okay, so compilation. You take the thing made out of text and you turn it into the thing made out of computer, right? Okay. And then generally speaking, we run the command with the // prefix. So dot means where I live right now. / means something within where I live right now. Main is the name of the file. And then the command line can interpret that as instructions, right? And this doesn't work particularly well for hi.js. And there's a variety of things we can do to make that work if we want to. Okay. So Python 3 is the program that reads a text file and does some stuff. Main is a program created by a different program, Rust.C. So we have two different types of programs. I just think of this as a graph that has a slightly higher length. Instead of creating a file and then running it in Python, we create the file, we compile the file, and then we run the file that we create. Okay. Some advantages to this. The obvious advantage is that you only have to compile once to run many times. But in order to convince you that that's useful, I have to convince you that having a compiled program is faster. Now, there should be like an obvious way to do that, which is that I have something on my computer called PyCache, which means that Python is doing something sneakily only one at a time. So the Python people are sort of trying to get as much compilation as they can, but that's cheating. I don't know what's in here because I'm not a programming languages researcher. That looks an awful lot like they're compiling Python programs into something that probably looks a lot like C, and then using components of pre-compiled code to accelerate Python. But I don't know why they're doing that for a Hello World print, which is probably not going to be that slow anyways. Okay. So, my impression, and I guess I believe this, is that no one ever uses Rust.C. I had to teach you Rust.C so I could give this lecture, and also because the Rust people recommend it. But the thing with Rust.C is it's not very automated. It doesn't have a lot of the nice automation approaches that we have, especially in modern programming languages. And it's really easy to make annoying forms of mistakes when using Rust.C. So some things that have changed since 1949, before computers invented, it is often the case now that a program is compiled from multiple files. We all love CS151 in this class, so we remember implementing enigma-rotor.py on the fourth project in that class, and that is the one-indexed fourth project because the projects are one-indexed in that class, right? So that's Enigma, where you pretended to be either Alan Turing or someone that was trying to invade Britain. I don't remember which side we were on. And you learned about objects by creating a separate file that modeled the Enigma rotor, right? That's kind of a new thing that can only exist after the files abstraction exists, right? Some compilers predate that. There are also libraries, and some of them are really cool. The example of the cool library is NumPy, Numerical Python, which allows you to do vector operations. And we all love data science here, so Pandas is an example of a library, right? We all love the Pandas data frame. Should I make you all clap for the Pandas data frame? Do we want to do that? Yeah, let's hear it for the Pandas data frame, right? Before Pandas, there was no way to put data into panels, right? Before that, we could only put it in frames. So that was a huge loss. And in this class, I am dictating to you extremely precise requirements for your file system, mostly so that I can make sure that I can tell you you have to do something, and then I can demonstrate your learning that you've actually done the thing. So for example, I required you to create a markdown file in a folder named 01. The problem all of this causes, and it should be clear to you as I'm precisely dictating certain file system arrangements to you, is that it can be hard to specify all of this stuff, and it can be hard to make sure everything's working together. So Rust just banned you from doing that, and is going to use a built-in manager to do it. There isn't a great equivalent to this in Python, and I'm going to talk a little bit about Python because I feel like we're a Python program. Python is not usually compiled, but there do exist compilers for Python, so I can write a Python script, run a program over that Python script, and get an executable back. And the most common way to do this is with Numba, which actually doesn't do those steps. What actually happens with Numba is you write a Python script, and then at the beginning of the script, you type import Numba, and Numba does all of that other stuff under the hood and saves your compiled program and doesn't tell you it has it. Numba is really cool, and it got used a lot in the financial industry before it lost the war to Julia, which is now considered more performant. But Numba's really slick, and you can check out my slides on Numba. I don't totally understand it yet, but it looks really cool. And I used it to make a Julia set here, which is my background. So you can check out Numba if you are looking for something to do with your free time. We don't quite have a build system equivalent in Python either, because we don't habitually build projects when we're doing Python scripting. My preferred equivalent to sort of teach you how to think about this is that you have worked with Python packages like NumPy, and those are in fact built, and they tend to be built with package managers. So the package manager I've used in Python, which builds something called a Python wheel, is called Flit. I think it makes sense to think of the Rust sort of programs you're creating as being closer to a released package than it does to thinking of them as a script. So I'm teaching you this for that reason. So there's a sort of novel problem that Python programmers may experience, which is not, hey, I need to write some lines of code that do some action, but hey, I need people around the universe to be able to use this, combination of functions or something I wrote, some library, right? And I need to distribute it, and I don't necessarily want to just distribute it as a text file. I want to distribute it as actually executable code that can be run and be packaged. And so Flit is one solution to this, as are Hatchling and what are the other ones? Setup tools is the other one. So we can imagine, for example, that when you use NumPy or Pandas or scikit-learn or Matplotlib, or in fact we could package the portable graphics library from CS151 in this way, and in fact Pygame is very similar and is packaged the same way. You can take these sort of big, diffuse Python projects and compile them into a wheel. And instead of running the code, which you do with, say, Python 3 my code, you put them all in a directory, you type flit init in the directory, which sets everything up, and then you type flit publish, and it throws everything online onto the Python, what's pip stand for? Python package, those are both P's. Pip. I don't know what pip stands for. Okay. So, perhaps this term, it is more useful to think of yourself as writing packages than it is to think of you as writing scripts, if those are sort of the concepts that exist to us. So, we are not creating necessarily this term just the notion of a .rs file, but we're creating the notion of distributable code that can be used on other places. My impression is some of the people that got really into writing Rust do think of Rust very concretely in this way. There is strong support for writing at least Python packages in Rust. I think there's strong support for writing R packages in Rust. Everyone's like writing Rust for fun all the time now. I don't know why. I do know why. It's because it's cool and good. And everyone that likes Rust is also cool and good.
I agree.
Okay. All right. And so sometimes you just want to write some code, be confident it works, and be confident it's fast, and Rust is a good way to do that, and then you can recycle it a bunch in Python where you're doing rapid iteration, right? So this is how we are going to introduce Cargo. Cargo is not quite pip, it is not quite Python, it is not quite Flit, but it is kind of the combination of these things. Rust C doesn't really figure into this anywhere. We're just going to use Cargo. As far as I can tell, everyone except the operating system developers, which might be us next term, use Cargo for everything. And we're never going to think about Rust C again, other than understanding under the hood the turning text into machine-readable stuff is happening. So, we're going to begin by introducing Cargo New, which is the first thing we use when we're working with Cargo. And at this point in time, I think we'll probably want to start following along. So, we're going to create a Cargo New. And this is kind of like creating a new .py file, but not really, because it's sort of going to have a notion of virtual environment, and it's sort of going to have a notion of version control, and it's going to have all this stuff. So it's actually much closer to Flit init. And I'm assuming you've never used Flit or any other sort of package distributor, because why would you do that, right? But if you have, it's similar. So let's do that. I'm going to unfull screenify, cut my screen in half. God, that's not half. Okay. I'm going to go over to the terminal. I'm going to... The terminal's not cut in half? Why is the terminal not cut in half? Does anyone know how Windows work? Okay, I'm going to clear my terminal. Wow, there's a lot of stuff here. I'm going to remove main, all of the mains, and all of the highs. Okay, that's not quite as bad. Okay, let's move into temp, actually. I said move into temp. Oh, wow, there's already stuff in here. I probably don't need whatever that is. Do we think that was important? It's extremely gone now. Okay, and I'm going to type cargo, new. I'm not going to type throwaway example. I'm going to type TAE because that's shorter. Okay. And what's that? Well, no, okay. There's nothing there, right? Folder empty, right? Do I need to open my visual file GUI? Well, trust me. Okay, there's nothing there, right? It's just like a place where there's nothing. Okay, so there's nothing there. We're going to cargo new, throwaway example. And then I can't deal with this being on multiple lines. Creating binary application. There's some joke in here about Rust being binary. I don't know what it is. Okay, note see more cargo. Okay, that's a lot of text. Okay, there's TAE, and TAE is in the bluish color, which is different than the file whitish color. That actually could just be white, actually, because TAE is not an executable and it's not a file. It's a bunch of stuff, and so it's full of nonsense. Well, okay, it is a folder, but the contents of the folder are much more relevant than it being a folder, right? So, like, why is it a folder? It's a folder because it has a bunch of stuff in it, not all of which you necessarily want, but all of which are used by Cargo to achieve goals, right? And so, let's take a look at TAE. I'm going to tree TAE, and I don't know if you have tree on your device. On my device, I get it with sudo apt install, and on your device, you get it with the package manager of your choice. What's my password? It's password. You can always get into my computer. So you can see tree TAE, and this shows me, or I can list the contents of TAE, or I can do an extended listing, right? So when I cargo new, I do not, importantly, get just main.rs. I do not, in fact, just get cargo.toml, and is that Tom's obvious markup language? Which is one of the markup languages we use to describe things, right? It is also relevant. There is a directory structure, right? So the code is hidden in something called source. And I kind of expected there to be Git in there, actually. I'm already in a Git directory somehow. No, I'm actually in a repository. So it suppressed creating the .git file because there's one here, which is really not great for my following example, but that's okay. All right, so let's go into TAE and check out what's going on in there. Okay, so we created cargo new. Cargo new is a folder that contains a specific directory structure. I do think it is inappropriately non-restrictive to just describe it as a folder. What it really is a package implemented in the file system. And I'm not just saying that because the peanut gallery was roasting me for this, okay? The entire last semester was like this, and I thought I was finally free. Okay, the most natural thing is to see what has changed. We've done that. Okay, there we go. Here's tree. There we go. Let's take a look at main.rs. There's two obvious ways to do this. We can, what am I doing? Oh, it's right here, okay. We can Catherine main.rs, so cat, short for Catherine, source main.rs, can I? And we can see, oh, it's the hello world thing. And then we can also, not Vimothy is, I guess, what mvim is short for, source main.rs. You know, yeah, I know I should have the alias to v or whatever. Like I have any idea how to set up aliases on my computer, right? Okay. And we can change this to hello cargo, most obviously, right? Okay, so those are sort of all of the different things I can do with this directory that has been gifted to me by my friendly neighborhood package manager, Cargo. The name main is basically mainful or meaningful, or I don't know, to Cargo. It says which, if multiple .rs files to read first when trying to execute code in a package. And we can demonstrate some corner cases of there. Okay, so I think cargo run is the closest equivalent to saying Python 3 some script because that's what's going to run the code. It is distinct because it's actually closer to saying flit init, flit publish, pip install, import, because it sort of goes through all of those steps in the process. It packages something up as a package and then invokes the package. But it's going to feel the same as if we just run the script. So, okay, two things to emphasize. I'm murdering throwaway example. When I do cargo new, I cannot just write cargo run immediately here. I'm expecting this to be a common error because you have to cargo run from inside of the package you created. So after you cargo new, you have to cd into the new, or get there however you like, right? So I'm going to cd into TAE, and from there you can cargo run. Maybe this is also slightly different from Python because you would create the file in the same directory. So this is, I'm emphasizing that on this slide. I'm concerned that will be, so you cargo new, you enter into the new space, and then you cargo run from within the new space, right? It's like you can't ride the rides in Disneyland without entering the park, right? Anyone love Disneyland? That's good. That's what we like to see. You know, for a while there, we thought the Marvel films were going to be good. That was a dark time. Or perhaps a bright time for the mouse. Okay. Here's a fun fact. I mean, all facts are fun, right? But like, this is a particularly fun one. If I run cargo run twice, this time is different, and it's much faster the second and successive time. And the reason for that is we're skipping this step. The first time we cargo run, we compile something, and then on successive times, we simply run the code. And the code probably lives in target debug TAE. Let's check.
Tree it now.
Ooh, yeah, let's tree it. This is going to be visually painful, okay? This is, the first time I typed this, I went into Discord and said, I refuse to teach Rust, and Indy and Jimmy bullied me into doing it. So this is awful. Okay, so there's a cargo lock, which is probably important. These are the things we started with, right? But look at all of this stuff, right? So we have a target, which is what you're targeting for compilation or for package release, right? We have a cache directory.tag. What's that? Who cares, right? We have a debug. We have builds with dependencies. We have why are there examples? We have something that's incremental.
Is it any little rummy examples in your documentation?
But I don't. I don't have them.
Fair enough.
Why would I have them? Right? So I think these are all like partially compiled. I don't know. I'm assuming that they're linking binaries, right?
Partial compilation.
Yeah. And okay, so far be it from me to say something negative about our most beloved programming language, right? But does it need 6 object files to compile Hello World?
Can you do it better?
Yes.
Oh, okay.
Thank you for asking. Okay, so we're going to make a directory called goodlang. We're going to cd into goodlang. We're going to mvim hi.c. And, you know, I don't even have to include it, right? Like, why is this banned? Here, we'll do a new line. Because, like, Rust is, like, new and cool. They throw new lines at the end of your print statements because they think you want that. I don't want that.
It's different.
No, it's bad. It's bad and wrong. And you can say, oh, yeah, sure, there's, like, other macros. First of all, I didn't read the documentation. And second of all, they give you print line directly in there when you type cargo new. Right? They're trying to force their beliefs on me. That's fine. Okay, hold on.
But it's not Rust, so it's bad.
Well, but
Also, when you used Rust C, it had that same number of files.
it's true. Use CMake and review that.
So what we're saying is Rust C is good?
Sure.
Because it has a C in it, right?
Hate cargo, not Rust.
Hate, okay, yeah. Make directory, hate cargo. CD, hate cargo. Oh gosh, live coding Rust is like one of the most existentially terrifying things I've ever done in my life. Is it this? No way is that right. That looks exactly the same as C.
It's not.
Okay. So, actually the enemy is cargo, not Rust. Okay, alright, fair enough. Let's go back to teaching you cargo. I hope we all had fun with whatever it was we were doing. Okay. Oh, what I should have done is I should have run it twice and timed the difference.
I did notice by default when you use Rust-C to make your Hello World file, the binary would be like 4 megabytes or something.
Oh yeah, let's check that. Okay, so we hate cargo. ls hate cargo. Or, yeah. Did I? Oh, I'm in TAE. Okay. So that's however big that is, which is some large number. We think that's, okay, that's 3.7 megabytes. Okay. And then in TAE, target debug main? Is it just called ta?
Yeah.
Is this right? Oh, it's the same size. Oh, it's actually bigger.
Because you do cargo build with like the release option, which makes like a normal set binary.
Ooh, that was fast. Did you see how fast that? So last time it was 0.25 seconds.
Well,
So
because it's kind of
yeah.
slower. For this small of a thing, having to debug symbols up on that is going to be slower.
So what you're saying is cargo's bad. I'm glad you're here today. This is actually very helpful for me. Okay, and let's look inside target. I think there's probably something in there called release. Yeah, okay. Release. Okay, and then let's see how big that is. And that's tiny. That's only half a megabyte. And then, how big was our C file? It was in goodlang. Did it? Temp goodlang. It's probably called a.out, right? Ooh, that is 50 times smaller. So yes, I know I can minimize my binaries. Anyways, I was hanging out with the other faculty because we don't have friends, and they were talking about like, hey, I heard some people like Rust language now, and then like looked at me, and I was like, yes, the students. Okay. Anyways, so I think we're back in our package, right? And I think we should demonstrate what happens if we put a file in our package that isn't named main. And then, like, presumably you can.
You told people to use Neo in this class.
Wait, what?
You told people to use Neo in this class.
I think I said use NeoVim, Vim, or Helix.
Did you tell them how to set up like a language server?
No, because why would you use a language server? We talked about this. Do you use summons in Dark Souls?
Like Dark Souls.
Right, so that's a no. So why would you use a language server, right? If you would like to learn about language servers, India will be giving a talk at the Quad Center about that later this semester.
I will. Sure, I guess.
Okay, thank you.
Come to the Quad Center, I'll have more things.
And separately, I think there will probably also be talks about using Arch and Nix, which are also encouraged for use in this class, right? Okay, you are always welcome to come to my class and offer to, participate or anything, but you should expect to be called on for guest lectures. And I think we will have a variety of guest lectures this term. I'm actually very excited. Some of the content I've put in this class is specifically things that I know other students want to teach about, so I'm trying to recruit them to teach those lectures instead of me. And I think that'll be positive for you and the students. Anyways, if you do have any questions about using console-based text editors, Quad Center is fine for that, right? And I'm trying to narrate to some degree what I'm doing, and I'm narrating less this week than last week. Okay, so let's make another file, and I'm going to vim source.secondary.rs. And I'm going to put some stuff in here. I'm going to make a function called secondary. Should I call it the same as, we'll just call it second. And it's going to print, it's only going to print something. Why are we printing something? Well, I just want to verify if it's run or not. So that's kind of all I care about right now. So we'll just do something. And from there, I can cargo run. And I only see hello world. Oh, and that's shocking to me, right? That's shocking and horrifying because I expected to also see something, right? Unless I didn't expect to see that. Because the same way we don't expect Python files to just spontaneously be run when we run an unrelated file in the directory. All files other than main are unrelated unless they are somehow invoked or used or expressed from within main. Now, there's another magical thing going on here, and I think I'm going to have to execute a series of swaps, so I'm going to pull up the slides and make sure this is working. Okay, so we still see hello world. Now, I'm going to do a series of moves, and you watched me, like, my brain fall clean out of my skull when I tried to do moves earlier today, so this is really stressful for me. But what happens if we just change what the main file is, right? Is there anything intrinsic or special about that file? No. Names are only given meaning by Cargo, and so when we change the name, we will change the meaning. Okay, so I'm going to cd into source so I don't have to type as much. Here I have main and secondary. I'm going to move main to old, and I'm going to, because I didn't say rs. Move main.rs to old.rs, and I'm going to move secondary.rs to main.rs, and then I'm going to go back up to a previous directory with cd ... and then I'm going to cargo run.
You don't have to go back up.
You don't have to go back up? You can do it anywhere in the project?
I think so. I don't know if you're like in the weird directory, but it probably just looks like
Yeah, it looks like you can do it anywhere. I like being at top level. Okay, cargo run. And this is not allowed. Why is this not allowed? In addition to having a file named main, you must also have a function called main. We saw this with our rustc example. Hate. Hate is such a strong word. Oh, I see what we're saying. It's actually hat ecargo. That's fine. Okay, so we're hat ecargoing, right? And I can cat main. Oh, that's not the one I wanted. So this thing has a function called main in it, and if it didn't, I meant to do that. You're required to have a main function inside your Rust file, and then separately for rustc, and then separately cargo requires you to have a file named main.rs, or to otherwise specify the name using different options. Okay, is that correct? I had to put a caveat on there because
well, I don't know. They can only have one main function.
you can only have one main function. Yes. Okay. And we're in T. Okay. Okay. Are you all following along okay? Does anyone have any questions? There's no questions. So, okay, I'll ask the obvious question. Professor Galvin, why don't we get to learn C89 this term? It's because I was bullied. Okay. We can fix this, and this being the error we saw, and it is simple enough to fix that error. We do exactly what we do exactly what Cargo tells us to do. In fact, I think actually this part is rustc being told by Cargo to tell me to use something, right? So I'm going to go to line 3 in mainers.
3 column 2.
3 column 2?
Yeah, that's the second number.
I believe you. Okay. Wait, no. Oh yeah. Okay, this is wrong, right? There's no main anywhere. Oh, because it's at the end.
Yeah, it just points to the end of the file.
That makes sense because that's where the arrow is pointing. I'm a visual learner. That's completely fake. I made that up. I lied. Okay. And now we can see something. So what was the process there? I created a main that contained a main. Cargo ran, and I saw the contents of main. In order to get something else there, I have to both change the name of the function and the name of the file. So specifically, cargo run will look for a main function in a main file. Basically, cargo is looking for the main file, and then rustc is looking for the main function. But we don't have to think of them separately in our minds unless we want to. That was fun. Options. Carry on only. Do you all hate paying for bags? Yeah, that's cursed. Back when I was a child, we got to fly for free both ways downhill in the sun. Okay. A fun fact. Okay, so I am so old. I'm older than the global war on terror. And when I was a small child, you could just ask the pilots if you, like, as a small child, could go, like, sit in the cockpit and look at the buttons. And apparently you could even, like, press some of the buttons because most of them aren't hooked up to anything. So I got to do that, and it turned me into the person I am now. So you can think of that what you will. Okay. So, some things are good and some things are bad about cargo, but I think someone, not me, suggested we should hat e-cargo, right? And that's bad. Cargo's good. We like cargo. And one of the things I'm going to ask you to do with cargo that's going to be non-trivial is I'm going to ask you to create folders that have certain names, and not all names are allowed in cargo because cargo is totalitarian. And the other thing I'm going to ask you to do is I'm going to ask you to place cargo projects with an existing GitHub directory. There is a corner case where this can solve errors, and it was enough of a corner case that I encountered it and had to figure out a solution for it. I am hoping you do not encounter this corner case, but I am also going to teach you about that. Those are called options 1 and options 2, which are options we supplied to cargo when we are specifying cargo new. I'm going to ask you to work through those things for the lab portion of our section, and then you have an exercise at the end which is going to apply them. Does that all make sense? Can I hear some like heads rattling? Yeah, cool. Okay. So you are on options, which you can get to by clicking over here on the far side of your screen. That's so tiny. I'm sorry. Wow, that is... Okay. Scroll down, options, right? So you might be in the slides. Okay, maybe you're not in the slides. You are on packages, and then you click on options. Options will introduce the exercise. All good? Okay, start working on that. I have to help some people with some things, and I have to try and learn all of your names, which I still don't know. Do you have a question for the whole class?
Options is blank.
So you probably cached an older version of the website, right? Because I'm live.
Yeah, you can try a Shift R to reload.
I'm doing that here. My computer just hates me.
Okay, so if that's still the problem, there's another solution, which is you can go to the repo, download that, and open the files locally. So that is GitHub CDC89 RS.
You have a different page.
Oh, go to taxes and then go
Oh,
to
wait,
options
okay,
here.
I see.
Oh, I see. Yeah, yes. No, I get it. That was an obvious error.
It's not that options.
Yes, it's a different options.
Yes.
Oh, that's so annoying. Oh my gosh. Oh, I hate that. It's actually been really hard to avoid namespace collisions. So, by the way, this lecture was previously named both build and cargo, and both of those are reserved names. And then I was going to call it make, which you obviously can't do. All right. Okay. Hope you're all having fun. Wait, why am I showing the wrong one? Okay, work on Numba. Okay. Oh, I should turn off the